Good evening, everyone. Right, we are having our final push with regards to our revision exercises. Right, today we want to continue with isometric drawing. This will be the third task that we are doing with regards to isometric drawing. Remember, we are now looking at past exam papers. So the one that we are looking at today, right, is again question number 3, right, of paper 2. Right, it's isometric drawing. Right, it's a revision exercise. It's a past exam paper, which is of Feb and March 2017. Right, let us look at these approaches and see how best we can utilize the techniques that we are going to acquire in terms of our own application, right, at home, right, in terms of your revision exercises. The most important thing is for you to be able to apply these techniques independently. Right, so let's get straight to it and look at this task. As always, we want to emphasize that you need to make sure that you are able to see clearly what we are doing so that you'll be remember all the steps and all the techniques that we are imparting right now. You also need to make sure that after this lesson, you take your drawing board, your drawing paper, your pencils, and all that you would require in order to also do the same task. Please make sure you time yourself. All right, of course, I would spend more because of explanations, but as part of your practice, make sure you don't spend more than 30 minutes on a question like this. Right, whatever you find as a challenge, you leave that, just dwell on that which you are able to do and do properly. Right, and move on to other questions like your question number 4. As always, I would urge our learners to start with question number 1, go to question number 4, come back and choose either question 2 and 3, do it. If you still have got time, then do the 4th question. Right, we would find that with question 1 and question 4, right, and any other of the 3, of the 2 remaining questions, you would end up getting a distinction if you do those questions successfully. I'm not saying deliberately leave the other 4th question, but manage your time in an exam. Thank you. Enjoy this lesson. Good luck. Right, so this is the task that we have today, right? Like I said, it's from March of 2017. It was a supplementary exam. So we want to look at this and answer it together and see how best we can negotiate our way to the required answer. Right, so the question would read, question number 3, isometric drawing. Given the front view and the top view of a bracket, so we have got the front view, we have got the top view. Remember, as always, right, in paper 2, we make use of third angle orthographic projection. So we have got our front view, we have got our top view there. The position of point S on the drawing paper, we have got point S, which is here, which we said it is regarded as the lowest point in terms of an isometric drawing, or it can also be regarded as the closest point to you as an observer. Right, so we want to look at that. Using a scale 1:1, convert the orthographic views of the bracket to an isometric drawing. Right, okay, so we need to convert this orthographic projection, which are 2-dimensional views. We change them now to a 3D, right? Which is a pictorial drawing. Make S the lowest point of the drawing. I've already explained that. That is the point closest to you. Right, show all constructions, no hidden detail is required, okay? Right, so the first thing, like I've always said, right, is the establishment of the isometric box. Right, so draw a faint line to the right, another faint line going up, then we have got this, right, which is going to the left. Let me just push this one slightly, but we need to see those measurements. Right, if you look at this, we have got from this point to that point, that's 136, but from the other end, right, at the top view, we have got 58. So we are going to say 136 plus 58 will get 194. Right, remember the isometric box, it's about defining the overall space that you will need. So we have got 190 here, then 194 there. Right, and we draw a faint vertical line from here, like that. Take this one down slightly. Right, the next thing, we need also the overall width. We are getting it from the top view, which is 80 millimeters. So we come here and measure 80. And we take this one up faintly like that. Right, then the last thing that we require in terms of the isometric box is to define the height. We are given that the height is the overall height from the bottom to the top, right? It's 75, so we measure 75 from here. We go to that, a bit slightly. Right, okay. So that's what we have in terms of our isometric box. We shall bring this one down slightly once we have defined that detail. Then the next thing that we want to look at, now you start with the definite, easy details that you can easily define. We have got the distance from here to there, which is 32, right? So we measure. Right, we have got that. Then we also take it to the left, like that. But once you have done that, right, But the first part that we require is not going all the way 80 millimeters. We just need one which is 60 millimeters. So we are going to do this. Measure from here to there. Like that. Then we take this one like this, right? We are not going to draw all the way, right? Because the detail may not go all the way as well. Right, okay. Now, the next thing that we want, right, there is this part, which is sort of a hexagonal part. All right, we are not given the height from here to there, right? So what we need to do, right, is to create an auxiliary view. So we can come here like that. And we take this one up. Right, the side of that hexagon is 36. So we can measure 36. Right, like that. Take your canvas. Right, if you check with regards to the information that is provided, the distance from here to there, which is the same as from here to there, is equal to 72. So 36 times 2 would give you 72. Then you mark this side, and you also mark that side. Remember, you can do this using a set square. Let me just illustrate that. Right, from here to there, you have got that. I would make this one slightly dark so that it will show our auxiliary view properly. Right. So we do have our auxiliary view. So this point is that point. Right. So what we need to find is what is the distance from here to there. We realize it's 50 millimeters. So we can also come here. And measure 50. And draw a faint line like that. Right, so we can take, right, the measurement from here to there to establish the height. Right, it's either we can measure or you can take that measurement using a canvas. Take this measurement like this. Then we stand here and we describe an arc like that. And we draw a line like this. Right. Once we've done that, we take the distance from here to there, which is the same as from here to there. Right, and step or mark it off either side. Like that, okay? We know that the distance from here to there, it will remain 36, which is our radius. So we can either take it like this, right, and stand here and mark off this and that. We can now connect this to there and this to there. It's already there, and that one to there. Right, so that we create our hexagonal part. Now, at this point, if you are confident, right, there is nothing that would stop you from outlining those details so that you are able to see going forward where you are going and where you are coming from. So we can outline this. So that's a detail that's not going to change. We can also outline this. Like that. And we can turn it around and do this. Outline this one as well. Like that. Right. Any detail that would make it easier for you to understand and reduce confusion. That's what you should do. Right. Then we can draw a line from this point. Sorry about that. We do the same. Right. So we also need, if we check the thickness from here to there, right, that's 9 millimeters. So let's factor in that 9 millimeters. We can measure it here. Like that. We take this one all the way. We shall need that. Then we bring this one down like that. Then we take it to the other line, which is the 9 millimeter line. Like that. And we take it up. Then this way as well. So we can also now connect this point to that point. It's one and the same thing. Like that. Now, if you check, we measured from here to there, that's 9 millimeters, right? If you are doing isometric, the moment there's a vertical line or a line at 30 degrees, if I do this from this particular point, the distance from here to there is 9, and automatically this one also is equal to 9. So I can take it to the other side like that without measuring, okay? Right. If I want also 9 millimeters, because this from here to there it's 9 millimeters. If I want 9 millimeters from here to there, I simply bring this one down like this. Right. So the distance from here to there, it would also be equal to 9 millimeters. Right. If I take this now to the other side, like that, we now also have got a distance of 9 millimeters from there. Now, once we have done that, at this point, if we are looking at the information, so the point that we have established is this one, all right, which is also that one, okay, which is basically in line with the upper part of that hexagonal part, right? So I can bring this one down, right, where it is visible, bring it down like that. Now, I've got quite a number of lines that I can outline, all right? We can outline from here to there, we can outline from here to there, we can outline from here to there, and also that, and here, also there, okay? Right, and this can also be outlined So let's start with this one, which is the top part. Right, but let's do this so that we have got an approach, proper approach to what we are doing. Then we take this one from here. It's also 9 millimeters. We take it all the way to there. Then we have got this part. It has to be defined as well. But just start with the obvious lines that you are able to see. This one, that one. We also come here, this, the lower parts. Right, so we now outlining, right? This is from here to there. But when you get the concept right, isometric projection or drawing, it's very interesting and it's fun as well. All right, okay. So we can also bring this one. Now, this you can only do, right, if you are certain that the information that you are defining is not going to be affected by the other forthcoming information as well. Where you are not sure, don't outline. Wait up until you establish the whole information or piece of information. There you go. Okay. Now we also see that, right, if we measure from here going to the right, we have got 136. So from here to there, that's 136. Let's do that. It will give us something. Right, 136. So we get to that point. And we draw a line like that. Right, from the 136, we have got also information that we need to go backwards. We need to go backwards 36 millimeters. So let's find, let's see. Like that. Then we take this one up. We take that one up. Let's just see something here. Right, okay. In terms of the drawing, but we would find that this would be about the same point in terms of the line which is coming from there. But of course, we could have done that. It would have still given us the same point. Okay. Right. So now we have got the distance from here to there. Right. And also the other part from the other end, right, which is from here to there. Remember, at this point, if I were to project from here, like that, now this point is connected to that part, but we don't need hidden details. I'm just going to illustrate, right, faintly like that. So this point is the same as that point. This point is that one. So the distance from here to there is the same as that one. So what it means at this point, we can outline this like that, because this one is going up like that. So we can also do the same. So I take this one and project to there. But then bring this one down like this. There you go. So the next thing that we want to do is to continue with this, because that's where the end part is, to extend this one and also extend that one up. Right. You can see this point and that point, they are raised up. So we are going to extend this one up. Right, and this one too. Like that. Right. So from here to there, we have got a measurement which is given from the base, which is 48, right? 48. So let's measure from here to there, which is 48. Then we take this one up. The moment you do that, you take it to the other end, now to the 36mm mark, and you take it back like this. From this point, you can extend this one like that. So you now have got the raised part, right? But as you can see, this would run all the way from here to there, which means it's from here to there. Then we raise this, we raise that. Those are definite details that we can define. So we are not going to wait up until everything, because you are going to create a lot of lines and they may end up confuse you, okay? But this line, which is that line from here to there, which is that corner here. So we can take this one. Right, so there's nothing that would stop us from outlining this, right, which is to the other end. Right, so we take this one all the way to here. And we take this one down, right, which is this edge from here to there. Like that. Now, if you check closely, you'll find that there is a line from here to there. It's not disturbed at all, right? So let's define that line as well. Now, there's something that I want us to look back and check. We have got this line which would come here. So we would need to take this line backwards, right? If we are able to see it here, right, that would be the lower part of that thick 9mm thickness. So we'll take it from here. Like that. Now, we are able to see it partly here, right? So we'll outline this. Like that. Now, this lower part, it comes here, but for now, we are not going to outline anything. Then we take it like this. But maybe at some point, we might be able to see, but which is this, which is that, okay? Now, remember, you'd find that the thickness would be here in terms of that, which would be one and the same thing. So if we were to show hidden details, right, that would be the point that we require, like that. Right. And this would have been the point that you would also require, right? Then you go to the other side, okay? Right. We would turn it like this. Right. So later on, we might need to define that part if it is feasible, but we would wait and see. Right. Now that we have got this, right, as you can see, the 9mm would still continue, okay? Right, so we can take this, take it up, right, like that, which is parallel to this, then project it to the other end, like that. Now, the moment this line meets the vertical line here, right, you would have created a thickness, then you take it to the other end, like that. Right, so from here to there, right, is the same as from here to that point. Right, and if we want another thickness on this line, what we do is simply bring this one down. Right. This is meant to increase your speed, but at the same time, it is meant to make sure that you avoid unnecessary measuring. Just shape. Like that. If I want another thickness here, I would do this. Like that. Then take this one, check that to the other side, okay? Now, at this point, I can outline this, it's already outlined, but from here to there, which is from here to there, then I can outline from here to there, which is the same as from here to there. I can outline from here to there, which is the same as from here to there. Then define that, which is that, then outline from here to there. All that detail can be defined easily. So we'll start with this one. Right, we stop there. There you go. Right, okay. So once we have done this, right, if we check with regards to our diagram, right, at this point, which is this one and that one, okay, right, it has to go up to the highest point, right? So if that is the case, right, we can raise, right, it and it goes up to the end, which is the same as this one. So in line with this one, we need to take that one to the isometric box line. We take that one. It's like this, okay? Then we take this one up. Let's start with this. Like that. Then this also needs to be taken like this. Like this. So at this point, we can connect from here to there and connect from here to there, right? In order to create this slant, which is from here to there, which is the same as that one. So we would come here and do this. As you can see, we are not measuring quite a lot, but we rely on the original measurements that we did. Okay. Right. So this part, remember what you need to do when you are looking from this side, the information that is given here should basically should be reproduced by looking from that particular direction. Right. So from here to there, which is from here to there. But I think we need another line here, right, which we discussed in our last lesson to say at each and every point, make sure there is a line which goes to the left, to the right, to the left, to the right, and either up or down like that. Right. At any point, there should be 3 lines. So we can outline this. There you go. Right, we have taken this one up, projected it like that. Right. Then if we check, right, we have got the distance. Let us just verify something if this is correct. From here to there, that's 58. Which is perfect. Okay. Right. So the distance from here to there, that's 58. So we are correct. All right. Then we have got a measurement from here to there, which is 45. We need to measure 45 from here. Right. The 45 will now take us in this direction. Right. So we turn all the way to the end of the 80 millimeter mark, right, which is from here to there. Right. Remember, right, we also require a thickness of 9 millimeters. You do this. You project like that. We also require a thickness of 9 millimeters, a vertical line, like this. Then we take this one. Now, this is the inner position, so we can take this one down. Take this one down like that. Maybe we shall need that one later on. But for now, let us outline all the details that we have defined. Right here, at this corner, you need this. Like that. So we can outline from here to there, right? From here to there, and from here to there, from here to there. Right. Remember, you need to have a system, right, in terms of how you define your diagram. If you are dealing with the lines going to the right, you continue with that up until you are done with everything. This. Then I can turn. Right, our diagram is slowly taking shape. Then we connected this point to that point. As you can see, this is a flat surface, right, where we only have got a corner at this point, which we need to define. So let's project from here, just align. Like that. But we have got that particular corner, right? So we can also now outline this, which is the slant part. There you go. Right, I don't think there's anything that would stop us from seeing this, because that height, right, from here to there, that's 54. Let's see if we've got more than 54 or less than 54. Right, so the 54 would come somewhere here. Right, so this would be defined without any challenges. Like that. And this one too. So what we require now, right, if we check, right, with regards to the information that is provided here, right, we have got the overall height from here to there, right, that overall height is 75. Then the height of this one going downwards, right, it's 64. So we are going to say 75 minus 64 will get 11. So we are going to do this. We measure 11 millimeters here. But on the isometric box line, then we take it here for reference purposes. Then we take it to the other side. Like that. So this should give us a height of 64. But that should give us a height of 64. But let's measure and see, which is roughly 64, right, off by half a millimeter. Then the 64 is here, but there's also another thickness, right, which is from the top, right, which would still be equal to 9 millimeters, right. Let's see, we have got, it's equal to 10 millimeters, right. So we can also measure from here to there, right, 10 millimeters, 64 minus 54, like this. Let's see if it is visible. That would give us from here to there, that's 54, which is that point, okay? So that's where then you would find that we now can project. There should be a line, right, in that direction, but representing that upper part, right? Then if we come here, right, with regards to the top, we can see that there's a 13 millimeter, okay, right, to this kind of platform. Remember, that is also a platform which is 10 millimeters thick, right? So we need to measure on this, right? So let's extend this line like that, okay? Then we measure from here to there, 13 millimeters. 1, 3. If we do that, we now can connect with this point, okay? Connect with this point to that 13 millimeter. Not that one, which is here, okay? Remember, it's at this level. It's not right at the bottom, right? It's raised. If we check with regards to this one, it's not right at the bottom, right? It's raised from here to there, which is 11 millimeters, which we take from here. But then we measured from here to there, that is we also need to project this one, remember? Take this one 10 millimeter and we also project like that. Let's see what would happen. Take this one like that. Then take it to the other end. Raise it from here. We get a point like this. Then we connect. This point is connected to that point. It looks like it will just be one and the same line that we have, okay? Right. So we are going to outline from here to there, right, to represent this line which is from here to there. Right. So let's do that. Like that. Then this is drawn this way. Right. And this comes all the way from the top, which I said it would appear it's just one line from the top like that. As you can see, our diagram, right, is taken shape in terms of the orthographic views which are given here. Right. The last thing that we want to look at, right, there is also an opening here. Right. There is also an opening, right? We know that the distance from here to there would remain 9 millimeters. Right. So what we can do, right, we bring this one down. Like that. Right. So the distance from here to there is automatically 9 millimeters. Right, then from the top, we have got 18 millimeters. Let's see, slightly above. Like this. Right, then we also need, right, 18 millimeters because they said it's a square side 18 by 18. So we need to take from here, measure 18. Draw a line like that. Then we also draw another one like this. Okay. It's less than 9 millimeters, so we are going to outline this all the way. And we define this one like that. So that is the opening through, right? That is the opening that we are able to see, right? Which is that, which will be there on this platform only, right? Now, I think we have drawn everything that we require except now the circular part. Right, let's check the specifications. It's diameter 42, right, which means we need to create an isometric square. Right, we measure 21. Up and 21 down to make it 42. Like this. Like this. But if you don't want to waste the time, draw through the center. You can easily get the other sides. Right, so the distance from here to there is 21. The distance from here to there is also 21. Then we do this like that. We also come here and do the same thing like that. Now we have got our isometric square. But then from there we can create a diagonal. Create a diagonal like that. We have got a center there, right? So we can connect now, define that, cut the diagonal, we have got that, which is the point that we want. We do the same thing here. This is circle construction, right? So with this center and that center, you connect from here, you draw an arc, you stand here, you connect, you draw an arc like that. So that's our first one. Sometimes it's worthwhile just to test. So we can put it this. outline that. Then you go to the other side, stand at the established center, check, and also check this side. Then we do this. In a perfect world, you would not need to adjust anything, but remember, there is an element of human error which is involved, and this one is perfect. Like that. We stand on the other end. Just need to adjust a little bit. There you go. Right, so we have got our outside circle. Right, that's our outside circle, the first part of our construction. Then what we need to do now, that we need to extend this line to hit the isometric box line, like this. Extend this. Right, I'm extending this to hit this isometric box line, like that. Then you take it to the other end. To the next thickness, which is here. Then you take it backwards. This would limit the need for continuously wanting to measure, okay? You transfer this one now to here, like that. So a corner like this one is here, okay? Right. Then we can also project from here and also project from there, like that. Right. The other corner, which is like this one, is already defined, which is there. We take this one up. Right. We also take this one up. Like this. So we have created our second isometric square. But on that one, we also create a diagonal like this. It's very important. We transfer the center from here to that diagonal, the center from here to that diagonal, so that we don't need to do the same process, which is repetition. So we are going to simply transfer it like that. But what you would require, this center, you also require it on that other side, just for reference purposes. Right, the same applies with this one for reference purposes. Okay, we will go to that. Then the same applies with this one. Like that. So if I were to stand here, open to should be that point and that point, which is perfect. And I describe that. Right, as you can see, don't be tempted to simply draw an arc all the way. Right, you'd find that you may need to use the second diagonal in order to draw the other part. So I'm going to stand here on the second diagonal and open to where I stopped, like here. and describe an arc. It will be stopped by the outside circular part. That's like that. So if the examiners are marking your work and they see this, they will know that you know exactly what you are doing. It's like that. There you go. You would have constructed the circular parts. But the next thing that you would require is simply to define the center lines. I'm going to use a red pen and also show it this way, like that. So now your circular part is done. Remember, at some point we did draw a line and brought it there, right, such that there was a point here. But what it means basically is that we should be able to see. But we should be able to see partly. I'm going to use a red pen here to describe that part. Okay, right. It's coming from down there. Then we see it partly here. Then the one which is coming from the going to the right like that. Then we would also be able to see it partly like this. Again, you'd find that you'd get a mark for this, for that small little line and that one as well, right, together with the information about the circular parts. Right, okay, right. So I'm sure we are done with regards to our exercise for today. Right. We have defined everything that we wanted. I'm just going to graphically show something here. Remember, you don't get marks for that. Let me not do this. Right, so that is the lower part in terms of the inner part of the slotted square opening, right, which is here. Right, I'm just illustrating that part. Right, so this is it in terms of our isometric drawing for today. I hope you were able to follow all the steps that we have been making with regards to the construction of this task. And also, hopefully you enjoyed what we did today, right? It's important, right? Remember, if you don't treat practical subjects, technical subjects like hobbies, you'd find that you will not be able to master the art. So make sure you enjoy what you are doing, especially with regards to drawing, so that you are able to express yourself, right? We'll see you again tomorrow when we look at another task. It might not be isometric. We will just be touching a bit of this with regards to past exam papers. Like I said, in terms of our revision, let's limit it to about a period of 5 years going backwards. Do not go beyond 5 years because we need to look at the trends in terms of the examination techniques and ways of asking questions. Thank you. Enjoy the rest of your day and your evening as well. Goodbye.